Alright, so when you're dealing with radicals, level 4 involves a special rule that you need to remember with radicals moving forward. You cannot ever, never, ever, today, tomorrow, last week, 3 years from now, 40 years from now, ever leave a radical in the denominator of a fraction. It's not allowed. It's mathematically not simplified. It's like saying the answer to some math question that you got in class was 4/6. Not right. You need to simplify it. You get 2/3. In math, you need to always do that. That's assumed. A teacher will not tell you anymore that you need to simplify your fractions. You just have to. Similarly, if you have a radical and you ever write down your answer, and you write down, oh, you know what, I'm feeling pretty good about my answer. I got an answer of 3/√2. Guess what I'm going to do? It's wrong. I know without even thinking about it because you can't have a radical in denominator. This point forward, if you ever have a radical in denominator, you need to change it. You need to get rid of it. You need to move it. And here's the process that you need to do that. It's called rationalizing the denominator. Here's what you do. Very straightforward. If there's just a radical or there's no addition or subtraction in the denominator, for instance, if you see something like 3 plus √2, it's a different process, and we'll get to that eventually, not today. That's nothing to worry about right now. But as long as there's no addition or subtraction in the denominator, this is what you're going to do. The radical you're trying to get rid of, you're going to multiply on top and bottom. So I want to get rid of, in part A, the √5. That's the issue. I can't have a radical in the denominator, and it's √5 that's causing the problem. So I multiply both top and bottom of the fraction by the radical I'm trying to get rid of. And you'll see why. Now, the common mistake is somebody's like, oh, but they cancel. Let me just cancel them out. That's not right. Don't cancel them. You're going to see what happens. On top, when you multiply across, 8 times radical 5 stays as 8 radical 5. Okay? You can't multiply a number and a radical. They don't change. They don't do anything differently. They just attach to one another. Divided by. We learned earlier in this skill that when you multiply radicals, you just multiply the numbers. What's 5 times 5? You get 25. When you multiply the bottom, you get √25. And you might say, well, Mr. Rock, that doesn't help. We still have a radical in the denominator. Until you realize that on top you have 8√5 still. But what's the square root of 25? The square root of 25 is just 5. And unless these reduce, which they do not, that's your answer. 8√5/5. It doesn't look any prettier except that there's no radical in denominator, meaning you're good to go. Okay, so be very careful with that. Multiply top and bottom by the radical. Okay, one quick hint. If you notice, if you take √5 and you multiply by √5, isn't that like squaring it or multiplying by itself, right? Isn't multiplying by itself really means square it? And what happens when you square something that's in a radical? Well, the square and the radical cancel and you just get the number. So whenever you take a radical times itself, you just get that number out. Okay, so you don't even have to do the work on the bottom. You can just remember, hey, √5 times itself is just 5. Okay, so next problem, the radical 12, it's an issue. Okay, we need to get rid of radical 12. So we multiply top and bottom by radical 12. On top, we get 6√60. We get 60 because we have to do 5 times 12. On the bottom, technically, you get 12 times 12, which is the square root of 144. But what did we just say? If you have a radical times itself, you just get that number. So it's just 12. And that makes sense because the square root of 144 is 12. Now, we have to do factor tree for 60. It can possibly break down. So let's try it. I'm going to go 30 and 2. I'm going to go 15 and 2. And 5 and 3. We have a pair of 2's. So that means we have our 6 originally. We have our 12 on the bottom originally. But now we have times a 2 that comes out. And we have 5 and 3 that don't come out. So that means there's still 15 inside. When we do 6 times 2 on top, we get 12√15/12. And guess what happens? The 12's cancel, and we just get the square root of 15. Again, get rid of a radical in the denominator by multiplying by itself on top and bottom. The top will always have to simplify. The bottom will always turn into a nice number.